This is a whiteboard video of nerve impulse conduction. The image we have demonstrated is a neuron where nerve impulse conduction occurs. Down here we have an enhanced image of what goes on inside the neuron. First, the nerve cell is at resting potential, meaning there are more sodium ions outside the neuron and more potassium ions are inside the neuron. Next, a nerve cell is stimulated and the threshold stimulus is reached, creating action potential. When the cell membrane becomes depolarized, it makes the cell membrane permeable to sodium, causing it to rush into the neuron through the sodium-potassium pump. This makes the inside more positive than the outside. After depolarization comes repolarization, which is when the potassium ions leave the cell, making it more negative. During the refractory period, the cell is basically being prepared to be back into resting potential. Through the sodium-potassium pump, the ions are put back into the resting potential.
Here you can see this is a basic diagram of a neurotransmitter. Impulse travels down the axon toward the presynaptic nerve terminals. The vesicles containing the neurotransmitter move toward the membrane of the neuron at the end of the axon. The vesicles fuse to the membrane and then release their contents into the synaptic cleft. The neurotransmitter is in the synaptic cleft and binds to the receptor on the postsynaptic neuron's membrane. The neurotransmitter molecules are still bound to the receptors and an action potential passes along the postsynaptic neuron away from the synapse. The neurotransmitter molecules are released from the receptors. They are then taken back up into the presynaptic neuron through the transporter. Once inside the presynaptic neuron terminal, the neurotransmitter molecules are repackaged into what they first were as vesicles.